Okay, I think we're live. So yeah, today we started chapter 12 and we will write our first command line program with the Rust to finally reach this point. Okay. So yeah, accepting command line arguments. So yeah, I quickly passed through the intro. It says we will build some simple version of grep with the Rust just for learning purpose. There is already ripgrep created by Andre Gallant, has already created a full featured very fast version of grep called ripgrep. By comparison, our version will be fairly simple, but this chapter will give you some of the background knowledge you need to understand the real-world projects such as ripgrep. So yeah, we will use knowledge from chapter 7, 8, 9, 10, 11. So yeah, we also briefly introduce closures, iterators, and iterates objects, which part of chapter 13, 17 will cover in detail. Okay, so let's start. So section 1 is accepting command line arguments. So let's create a new project with, as always, cargo new. We'll call our project mini-grep to distinguish it from the grep tool that you might already have on your system. I actually already done it, so yeah. The first task is to make mini-grep accept is two command line arguments, the file path and string to search for. This is we want to be able to run our program with cargo run, two hyphens to indicate the following arguments are for our program rather than for cargo. A string to search for and a path to file to search in, like so. So two hyphens or two dashes is mean we pass arguments not to the run command but to the our binary built by cargo run command. And actually in my NeoVim setup I created plugin so I can quickly run some hard-coded params, so I can do like this, and you see I have arguments. First is the path of its relative path on target, debug, and actually mini-grep binary. And other two params is what we passed after two hyphens, like here. So yeah, basically if we do cargo run, two hyphens and param 1 and some other param, you will see it will be different. But just for test purpose, I hard-coded this command and can quickly run it like this. Okay. So right now the program generated by cargo new cannot process arguments we give it. Some existing library on crates.io can help with writing a program that accepts command line arguments, but because you're just learning this concept, let's implement this capability ourselves. Okay. Reading argument values. To enable Minigrep to read the values of command line arguments we pass to it, we'll need the std and args. So yeah, we can use this standard library functionality. Function provided in the Rust standard library. This function returns an iterator of the command line argument passed to Minigrep. We'll cover iterators fully in chapter 13. For now, you only need to know two details about iterators. Iterators produce a series of values, and we can call the collect method on iterator to turn into a collection, such as vector that contains all the elements the iterator produces. Okay. So I guess arguments is a iterator which produce series of elements, and we can collect it into the vector. Okay. The code in listing 12.1 allow you Minigrep program to read any command the argument passed to it and then collect the values into a vector. Okay. Yeah, I actually already start with this code snippet. So what it does, it collect the argument and print it with dbg macro. Okay. First, we bring the std environment model into scope with the use statement, so we can use it argument function. Notice that the std environment arguments function is nested in two levels of modules, as we discussed in chapter 7. In cases where the desired function is nested in more than one module, we've chosen to bring the parent module into scope rather than the function. By doing so, we can easily use other functions from std environments. It's also less ambiguous than adding use std environment arguments and then calling the function with just arguments, because arguments might easily be mistaken for function that define it in the current module. So yeah, instead of bring exactly the function args, we just use std environment, and when we call the function, we also have the parent module name environment here in the namespace. So it's much easier to understand our code, just for the convenience. So the argument function and valid Unicode. Note that arguments will panic if any argument contain invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use args.os instead. This function returns an iterator that produces OS string values instead of string values. We've chosen to use std environment arguments here for simplicity because OS string values differ per platform and are more complex to work with than string values. Okay. I don't think I need any invalid Unicode right now, but it's good to know for future. On the first line of main, we call argument function, and we immediately use collect to turn into iterator into vector containing all the values produced by the iterator. We can use the collect function to create many kinds of collections. So we explicitly annotate the type of arguments to specify that we want a vector of strings. Also, we very rarely need to annotate types in Rust. Collect is one function you do often need to annotate because Rust isn't able to infer the kind of collection you want. Finally, we print the vector using the debug macro. Let's try running the code first with no argument and then with two arguments. So yeah, I can show you. Yeah, sorry. Without arguments, you see this only relative path of our binary. And if we run with the two params, it also print param 1 and param 2. And in the book, yeah, we have exactly the same. Notice that the first value in the vector is target debug minigrep, which is the name of our binary. This matches the behavior of the arguments list in C, letting program use the name by which they were invoked in their execution. It's often convenient to have access to the program name in case you want to print it in a message or change behavior of the program based on what command line alias was used to invoke the program. But for the purpose of this chapter, we'll ignore it and save only the two arguments we need. So saving the arguments values in variables. The program is currently able to access the values specified in the command line arguments. Now we need to save the values of the two arguments in the variables so we can use the values through the rest of the program. We do that in listing 12.2. Okay, so this is what we have, and now we can create query and file pass. So let's do this. Let's have query and let's have file pass. And we want print searching for query and in file. Okay, it's not really a query and the pass, but we are fine with it now. We're not really doing anything yet. As we saw when we printed the vector, the program's name takes up the first values in the vector at the argument 0, so we are starting arguments in index 1. Let's quickly test what happened if we don't have any arguments. And yeah, the app is panicked. Okay. The first argument minigrep text is the string we are searching for, so we put a reference to the first argument in the variable query. The second argument will be the file pass, so we put a reference to second argument in the variable file pass. We temporarily print the values of those variables to prove that the code is working as we intend. Let's run this program with the argument test and sample txt. I actually want to try it's I remember we should have something like this, but instead of unwrap, I think we can unwrap or return the contain some value provided default argument wrap or agree to evaluate that in if you pass the result of function code, recommend to use. No, it's not. I actually want. I want just have a message. So panic of the sub value equal none. So yeah, let's quickly take a look in the book. Error handling. I already forgot what we used, but okay, I think we can use expect instead. Returns contain some value, concerning the cell panicked if the value is known with a custom panic message provided by message. Yeah, exactly what I want. So the program expect query as first argument, and let's do without any argument, and yeah, panicked at the program expect query as first argument. And yeah, let's do the same. Yeah, something like this. I feel more robust way, because like we just panicked and not tell anything to the user. So this works fine, but one, and file pass is second argument. Yeah, this is good. So let's continue. Okay, great. The program is working. The value of the arguments we need are being saved into the right variables. Later, we add some error handling to deal with certain potential and erroneous situations. such as when the user provides no arguments. For now, we'll ignore the situation and work on adding file reading capability instead. Okay, we will do it later, but yeah, we kind of work on it a bit ourselves, which is, I think, good. Maybe we will have something even better. So reading a file. Now we add a functionality to read the files specified in the file path argument. First, we need a sample file to test it. We'll use a file with a small amount of text over multiple lines with some repeated words. Listing 12.3 has an Emily Dickinson poem that will work well. Create a file called poem.txt at the root level of your project and enter the poem I'm nobody, who are you? I'm nobody, who are you? Are you nobody too? Then there is a pair of us, don't tell. They'd banish us, you know. How dreary to be somebody. How public like a frog. To tell your name the livelong day. To an admiring bog. Yeah, this is cool one. So let's add poem.txt and yeah, add the poem into the file. With the text in place, edit src main and add code to read the file as shown in listing 12.4. So the file we need stdfs first of all, so let contents fs read to string file s. Yeah, and here you see we're already using expect. Let's copy this error message. Oh my god. And yeah, print so file path is our second argument, so we can sample, not sample, poem.txt and quickly run it. And yeah, it's working. We can also try something else. And the thread main panicked it should have been able to read the file. Okay. This is fine. First, to bring a relevant part of the standard library with use statement, we need stdfs to handle files. In main, the new statement fs read to string takes file path, open the file and return stdio result string of the file's contents. After that, we again add a temporary println statement that print the value of contents after the file is read, so we can check the program is working so far. Let's run this code with any string as the first command line argument, because we haven't implemented the searching part yet, and the poem.txt file is the second argument. Okay, yeah, we already tried. We need two arguments, second should be poem.txt, and it's working. Read the code, read, and then printed the content of the file, but the code has a few flaws at the moment. The main function has multiple responsibilities. Generally, functions are clearer and easier to maintain if each function is responsible for only one idea. The other problem is that we are not handling errors as well as we could. The program is still small, so those flaws aren't a big problem, but as the program grows, it will be harder to fix them cleanly. It's good to practice to begin refactoring early on when developing a program, because it's much easier to refactor smaller amounts of code. We'll do that next. Yeah, this is part I really like, some refactoring. Refactoring to improve modularity and error handling. So now it becomes will look more something real. So yeah, that's why it's really interesting. So to improve our program, we'll fix 4 problems that have to do with the program structure and how it's handling potential errors. First, our main function now performs 2 tasks. It processes the arguments and reads files. As our program grows, the number of separate tasks the main function handle will increase. As function gains responsibility, it becomes more difficult to reason about, harder to test, and harder to change without breaking one of its parts. It's best to separate functionalities so each function is responsible for one task. Yeah, obviously, like for try something, we just pull everything in the main. It's usually the first step, but then when we have things working, we start in refactoring it. And yeah, basically each single task should be kind of a function. So I think we will do it something like this. This issue also ties into the second problem. Also, query and file paths are configuration variables to our program. Variables like contents are used to perform the program logic. The longer main becomes, the more variables we'll need to bring into the scope. The more variables we have in scope, the harder it will be to keep track of the purpose of each. It's best to group the configuration variables into one structure to make their purpose clear. The third problem is that we've used expect to print an error message when reading the file fails. But the error message just print should have been able to read the file. Reading a file can fail in a number of ways. For example, the file could be missing, or we might not have permission to open it. Right now, regardless of the situation, we print the same error message for every which wouldn't give the user any information. Yeah, this is kind of pity situation if someone try to use the program and it's not working and you don't understand why. So we would like to see like some meaningful information, like error message. So false, we use expect repeatedly to handle different errors, and if the user run our program without specifying enough arguments, they get an index out of bound error from the Rust that doesn't clearly explain the problem. It would be best if all the error handling code were in one place, so future maintenance had only one place to consult the code if the error handling logic needed to change. Having all the error handling code in one place will also ensure that we are printing message that will be meaningful to our end users. Let's address the for problem by refactoring our project. So yeah, it's nice idea to have like some logical piece like error handling in some one module, for example, and so you can easily go and check it when you maybe you're not familiar with the code base and you're looking at it first time. It's easy to understand, or you don't remember, like you write this code a while ago, so definitely makes sense to do. Okay, so separation of concern for binary projects. The organizational problem of allocating responsibility for multiple tasks to the main function is common to many binary projects. As a result, the Rust community has developed guidelines for the splitting the separate concerns of a binary program when main starts getting large. This process has the following steps. Split your program into main RC and librc and move your program logic to librc. As long as your command line parsing logic is small, it can remain in main RC. When the command line parsing logic start getting complicated, extract it from main RC and move to librc. The responsibilities that remain in the main function after this process should be limited to the following. Calling the command line parsing logic with argument values, setting up any other configuration, calling a run function in librc, handling the error if run returns an error. So basically, yeah, I like this idea when you start learning some language, technology, and you, at least for me, it's always a question how to organize your project, what is the best way, what the people use, and I'm really glad to see it this early point that Rust suggests us how people that use Rust have common practice and described in this book. So this is really cool. This button is about separating concern. Main RC handle running the program and librc handles all the logic of the task at hand. Because you can test the main functionality directly. Oh. Yeah, hi Justus. Let me quickly open the chat. So yeah, stream manager. Justus, hi there, how you doing? Yeah, we are learning Rust by reading the Rust book. Okay, yeah, it's Friday. It's actually like 9 p.m. where I am, so quite late. So yeah, it's fine to be tired. So yeah, let's back to the book. Oh, yeah, Germany is 1 hour difference. Kind of the same, so yeah. Good time to chill, watch some Twitch stream or something. So this pattern is about separating concerns. Main RC handle running the program and libRC handle the logic of the task at hand. Because you can't test the main function directly, the structure lets you test all your program logic by moving it into function in libRC. The code that remains in the main RC will be small enough to verify correctness by reading it. Let's rework our program by following this process. Okay, yeah, this sounds interesting. I'm not really doing Rust stuff. I just started learning it by reading the Rust book from, yeah, like the main official book. So yeah, but yeah, I have like programming experience, like working as a developer more than a decade, so I think I can handle it. I just want, yeah, to do it's like slowly to read all fundamentals with the books, like not jumping on some uh, this crash courses on YouTube or Udemy or something. And yeah, also trying to do streams, like learn in public, communicate with people, to hear their experience as well. So this is, yeah, the way I choose. And you see, like, I'm on the half. And yeah, you started a couple months ago. How you do it? What are you reading the book? Are you watching the courses? What the approach you took? Are you building some stuff with it? So we extract the functionality for parsing arguments into a function that main will call to prepare for moving the command line parsing logic to libRC. Listing 12.5 show the new stuff of main that call the new function parse config, which will define in the main RC for the moment. Okay. So few pages of the book. Yeah. Yeah, this is a nice way to do it, like just building something. I like this approach as well. Mm. But interesting thing from Rust, it's like have some unique concepts. Uh, at least I feel it like as I'm reading. At least from mm, knowledge from my languages I'm familiar with. So yeah, usually it's something for me. It mix kind of you're doing something, you learn from practice, but then you would like to go and like learn some fundamentals about what you're doing. And when you're already familiar with it in practice, it's much easier to understand theory. Okay. Yeah, I didn't really play around with any of this yet. So I building some CLI tools. Cool, cool. What is the purpose of learning Rust? It's just is a you're doing it like the hobby, or you would like to use it at work? So we replaced the logic of getting arguments with the function. We're still collecting the command line arguments into a vector, but instead of assigning the arguments value at index 1 to the variable query and the argument value at index 2 to the variable file pass within the main function, we pass the whole vector to the parseConfig function. The parseConfig function then holds the logic that determines which arguments go in which variable and passes the values back to main. We still create the query and file pass variables in main, but main no longer has responsibility of determining how the command line arguments and variables correspond. Some processor macro stuff. Oh yeah, this is cool. So yeah, if you're having fun right now, then in future might be a good choice for the work. Not necessary, but yeah. So what is the project? Can you send the link? Maybe I can follow. Maybe I will join. So this rework may seem like overkill for our small program, but we are refactoring in small incremental steps. After making this change, run the program again to verify that the argument parsing still works. It's good to check your progress often to help identify the cause of problems when they occur. So yeah, this is actually I feel this is really good way to introduction how to work with your code. First you write something in very dumb way, but then you looking how to organize it better, like splitting to the functions. Yeah, I'm actually doing some TypeScript as well for the job, but Rust looks like pop up in the web world more and more those days. So maybe it's a good bet for the future. 5 years, it's like, yeah, long time now. But what the project? Uh, I'm curious. Uh, Grouping configuration values. We can take another small step to improve the parse config function fuzzy. At the moment, we'll return tuple, but then we immediately break the tuple into individual parts again. This is a sign that perhaps we don't have the right abstraction yet. Okay. Another indicator that shows there is room for improvements is the config, part of parse config, which implies that the two values we return are related and are both part of one configuration value. We are not currently conveying this meaning in the structure of data, other than by grouping the two values into a tuple. We'll instead put two values into one struct and give each of the struct field a meaningful name. Doing so will make it easier for future maintainers of this code to understand how the different values relate to each other and what their purpose is. So yeah. So now we would like to create this struct config. Okay, it's on GitLab. Yeah, I just like searching GitHub every day, but not often came to the GitLab. Is GitLab has this feature of editor? But I need to sign in, right? Oh, so it's some, okay. Okay, I got it. Okay, maybe, yeah, explore it later. Just for fun. And this is like your own, is it some organization or are you part of some community? I don't know. What is it? Dem engine. Cool, cool. Yeah. Yeah, so definitely good luck and for sure have fun with your project. So where am I? Okay, we create a config struct and now we can use it as a return. So yeah, let's replace everything with our config. Okay, and we use clone here. Yeah, let's quickly run. Yeah, everything is fine. Hey Alex, how you doing? So we added a struct named config defined to have fields named query and file path. The signature of parse config now indicate that it returned config value in the body of the parse config, where we used to return string slices that reference string value in the args. We now define config to contain owned string values. The args variable in main is the owner of the argument values and is only letting the parse config function borrow them, which means we violate Rust borrowing rules if config try to take ownership of the values in arguments. So yeah, we're doing clone, and now query is have ownership, and then when we return we move ownership to the main scope. Okay. I'm good, did a bit of Rust for Advent of Code and have come back to try do some more project with Rust. This cool. What is actually Advent of Code? I hear people doing it, but never tried myself. Yeah, I don't face it yet, but yeah, I expect it when I start writing some code. But it's actually positive thing about the Rust compiler. At least what I heard, it gives you really good errors. So it's really good tips how to do it. Writing up. So this is some how it's called. Okay. Okay. Dark mode is better, at least in the evening. To make WebGL in Rust, is there some particular framework I'm going to use, or like I'm going to do it from scratch? Rust WebGL. Actually never work with WebGL. Okay. Yeah. So this is cool. Project should be. I used to work with OpenGL a while ago. It was really fun, but yeah, I think I lost all my knowledge of it a while ago as well. So we saw ownership here. So there are a number of ways we could manage the string data. This is so somewhat inefficient. Route is called the clone method on the values. This will make a full copy of the data for the config instance to own, which takes more time and memory than storing a reference to the string data. However, cloning the data also makes our code very straightforward because we don't have to manage the lifetimes of the references. In this circumstance, giving up a little performance to gain simplicity is worthwhile trade-off. Okay. Yeah, this is cool. Yeah, I heard about Leptos basically from the Prime Gen Twitch stream. Never worked with Solid.js, but yeah, using React. I actually wanna try Deoxys. It's kind of mix of Rust and web. Like you need to use CSS to style components, and it's like React, but it's really early stage. Oh, there is new blog post. Let's take a look. Hey folks, we are going to deviate from the typical release post or technical discussion and talk about the future of Deoxys. If you are new here, Deoxys is a UI library for Rust that supports web, desktop, mobile, live view, terminal UI, and more. Our goal is to simplify app development, combining projects like React, Electron, Flutter, blah blah blah. And the past. Over the past year, Deoxys has grown significantly. We made huge strides in pushing forward the Rust frontend ecosystem. Some of the amazing innovation in the space, including hot reloading, scene-based auto-formatting, and Deoxys Live View. Built on top this innovation and breakthrough projects like I don't know how to read it, but anyway, We want to continue innovating while also maturing Deoxys on all fronts. So it's actually started last year. The present. I'm happy to announce that I'm now working on Deoxys Lab full time, thanks to generous support of FutureWay, Satellite AIM, the GitHub Accelerator program, and several amazing individuals. Deoxys Lab is now able to employ both myself and top contributors like Demonsus full time. Going full time on open source is a huge jump. It takes a lot of courage to leave a company as great as Cloudflare. Being independent truly means independent, no work colleagues, no free snacks, no transit card, no beautiful office, and no company-sponsored health insurance. That being said, I'm eternally grateful to have the opportunity to pursue Deoxys Lab with my entire passion. We are committed to helping developers build better apps. So the future. We have big plans for the future. Here's a rough sketch of what the future holds Deoxys. So yeah, this is actually I was worried about, is this project have a future, and it looks like now it makes next step. So we have big plans, massive overhauled docs with tutorial videos and one-click deploy example projects, stable support of async components, suspense boundaries and error boundaries, stable release blitz, our HTML CSS render built on Velo with an open API, a development and release management platform for Deoxys based apps, and overhaul of the Deoxys router with support for many Next.js features, standard library of cross-platform functionality, GPS notifications, better dev tools. So basically, yeah, the project is alive. So definitely I will going to build something on top of it. But yeah, let's back to the book and the trade-offs of using clone. There is a tendency among many rusticians to avoid using clone to fix ownership problems because of its runtime cost. In chapter 13 we will learn how to use more efficient method in this type of situation, but for now it's okay to copy a few strings to continue making progress because you make those copies only once and your file path and query string are very small. It's better to have a working program that's a bit inefficient than to try to hyper optimize code on your first pass. As you become more experienced with Rust, it will be easier to start with more efficient solution, but for now it's perfectly acceptable to call clone. So yeah, we use clone here. We're doing it in a bit unsafe manner, but I think we will resolve it later. So we updated main, so it places the instance of config returned by parse config into variable named config, and we updated the code that previously used the separate query and file path variables to it now uses the field on the config struct instead. Result and options. Yeah, it was. Let me see. Command collection. Oh my god, where it was. Yeah. Error handling is chapter 9. Recurable errors. I'm actually doing like really slowly because yeah, I'm reading book on streams and it already a couple of months and don't have really a lot of time to invest in the learning Rust. Just like a fun hobby for me. Yeah, it's for sure. I did it, but for now I'm just trying to follow the book. I think they will cover this point as well. But yeah, I'm with you on it. When I see the code like this, I immediately think it can fail. It's not what I want to have in my code. If I do anything like this in this TypeScript, I definitely put option here, so do not break anything. Now our code more clearly convey that query and file paths are related, and their purpose is to configure how the program will work. Any code that uses those values know to find them in the config instance in the field's name for their purpose. Creating a constructor for a config. So far we extracted the logic responsible for the parsing the command line arguments from main and placed it in the parse config function. Doing so helped us to see that the query and file path values were related and that relationship should be conveyed in our code. We then added a config struct to name the related purpose of query and file path and to be able to return the values names as struct field names from the parse config function. So now that the purpose of the parse config function is to create a config instance, we can change parse config from a plain function to a function named new that is associated with the config struct. Making this change will make the code more idiomatic. We can create instance of type in the standard libraries such as string by calling string new. Similarly, by changing parse config into a new function associated with config, we'll be able to create instance of config by calling config new. Listing 12.7 show the changes we need to make. So okay, now we can do implementation of the config. And we put their reference to strings. and return config. And yeah, basically yeah, exactly. Was a bit distracted, so I lost where am I. So now we can replace our parse with the config new. Okay, it's working. So we updated main where we're calling parse config to instead call config new. We've changed the name of parse config to new and moved it within an implementation block, which associate the new function with the config. Try compiling this code again to make sure it works. Yeah, just did it. Fixing the error handling. Okay, this might be the part where we will avoid this problem with indexes. Now we work on fixing our error handling. Recall the attempting to access the values in the argument vector at index 1 or index 2 will cause the program to panic if the vector contains fewer than 3 items. Try running the program without any arguments. It will look like this. Yeah, we have panic for sure. The line index out of bound len is 1, but the index is 1 is an error message intent for programmers. It won't help our end users understand what they should do instead. Let's fix that now. Improving the error message. Listing 12.8, we add a check in the new function that will verify that the slice is long enough before accessing index 1 and 2. If the slice isn't long enough, the program panicked and display a better error message. So basically, if yeah, we did it in a different way, not using get, but just use condition args less 3 and panic macro. Not super descriptive, but anyway. So self, okay, so this is like this, right? So let's test the panic, yeah, without arguments, and with arguments with the self keyword. It also works. Yeah, this is interesting, thank you. So basically it makes our code like more universal. So if we will rename, we just need rename it something here, or if we copy pasting stuff, this could be beneficial. This code is similar to the guess new function from where we called panic when the value arguments was out of the range of valid values. Instead of checking for a range of values here, we checking that the length of arguments is at least 3 and the rest of the function can operate under the assumption that this condition has been met. If argument has fewer than 3 items, this condition will be true, and we call the panic macro to end the program immediately. With those extra few lines of code in new, let's run the program without any arguments again to see what the error looks like. Yeah, we did it. This output is better. We now have a reasonable error message. However, we also have extraneous information we don't want to give to our users. Perhaps using the technique we used in listing 913 isn't the best to use here. A call to panic is more appropriate for a programming problem than a usage problem. And this topic was discussed in chapter 9. Instead, we use the other technique you learned about in chapter 1, returning a result that indicate either success or an error. Yeah, I'm also learning English while reading the book. Thank you for the tip. So yeah, running result instead of calling panic. We can instead return a result value that will contain config instance in the successful case and will describe the problem in the error case. We're also going to change the function name from new to build because the many programming expect new function to never fail. When config build is communicating to main, we can use the result type to signal there was a problem. Then we can change main to convert an error variant into a more practical error for our users without the surrounding text about thread main and Rust backtrace that the call to panic causes. Okay. So listing 12.9 shows the changes we need to make to return value of function. We're now calling config build and the body of the function needed to return a result. Note that this won't compile until we update main as well, which we do in the next listing. Okay, let's just copy paste it. So what we have here, we returning error, and return of the build function will be result of config. Okay, this is something interesting. It's a lifetime. Yeah, I read about lifetimes, but I don't remember static lifetime. Um, okay, it was there, but just forgot it. Static, which denote that the affected reference can live for the entire duration of the program. Okay. So basically it will live all the time. But what will happen if we don't have it? Oh, the result have error type. So we use static lifetime. And if we'll have it without lifetime, it's not complain. Interesting. Oh, this is interesting. Yeah. So why we actually needed it here? I'm actually a bit confused. Yeah, let's continue with propagating errors. Yeah, wrong place. So, oh, there is actually explanation. So, our build function return result with the config instant in the success case and reference static uh, static string in the error case. Our error value will always be string literal that have the static lifetime. We made two changes in the body of the function. Instead of calling panic when the user doesn't pass enough arguments, we now return an error value, and we wrap the config return values in OK. Those changes make the function conform to its new type signature. Returning an error value from the config build allows the main function to handle the result value returned from the build function and exit the process more cleanly in the error case. So you probably don't need because of the lifetime elision rule, but the error you are returning is string literal baked into the binary. So one that is not dynamic in the error case, so it probably is a good practice to add it to the return type. Okay. So yeah, let's see. Because when I read the result section, I don't remember I saw any lifetimes here. Okay, but I don't actually use string slices there as well, so makes sense. Okay, calling config build and handling errors. To handle the error case and print the user-friendly message, we need to update main to handle the result being returned by config build as shown in listing 1210. We'll also take the responsibility to exiting the command line tool with non-zero error code away from panic and instead implement it by hand. Non-zero exit status is a convention to signal to the process that called our program that the program exited with an error state. Okay. Yeah. Uh, yeah, I think I just missed import. We use so the code actually fine. But so far this static lifetime isn't doing anything, right? It just like a notation. Yeah, I read about it, but what it will be printing? Let me try. An error. Okay. Oh yeah, yeah, it was also explained somewhere in the book. But in this case, you will not have this message, right? You will have some... Oh no, you actually will have this one. So yeah. Yeah, completely makes sense. But basically, all this stuff more for learning purpose. So map. Okay. So to contain it error value living and okay value untouched. So it's in case we have multiple errors. Okay, okay, I will note it for myself. So in this listing we used a method we haven't covered in details yet. Unwrap or else. Which is defined on result type by the standard library. Using unwrap or else allow us to define some custom non-panic error handling. If the result is an OK value, this method behavior is similar to unwrap. It returns the inner value OK is wrapping. However, if the value is an error value, this method calls the code in disclosure, which is anonymous function we define and pass as an argument to unwrap or else. We'll cover closures in more detail in chapter 13. Yeah, I haven't read about closures yet. but actually nothing esoteric here. For now, you just need to know that unwrap or else will pass the inner value of the error, which in this case is the static string, not enough argument, that we add in listing 12.9 to our closure in the argument error that appears between the vertical pipes. And the code in the closure can then use the error value when it runs. We added a new use line to bring process from the standard library into scope. This code in this closure that will be run in the error case is only 2 lines. We print the error value and the call process exit. Process exit function will stop the program immediately and return the number that was passed in the exit status code. This is similar to the panic-based handling we used listen 12.8, but we no longer get all the extra output. Let's try it. Okay. It's mostly like JSR functions, mostly equivalent. Okay. And like arrow functions, you don't actually need to break it if you're returning the value of the statement. Okay, cool. So yeah, I feel like I'm already tired and can't really handle information from the book. But yeah, it was nice to meet you, Justice. If you like, you can follow me. I'm doing those streams couple times for the week, so we can chat. Yeah, so thank you to being here. See you next time.